in this video, I'm going to continue processing my notes that I took on this book so far using the Zettelkasten method. And this time I'm going to be using my Neovim workflow. So if I open up my daily note, then we see here these are the links that I created earlier. And now I can just continue here. And I did this by running the zk day command. This is a CLI that I wrote myself. It has a few options that I did, and you can find the source code on my GitHub. It's called Zettelkasten CLI. You can use it if you want, but it's very bespoke for my own system. But I also have this command called zk new, and I'm now going to move towards symbolic and subsymbolic AI. So I'm just going to create a node called zk new symbolic AI. This is going to create a node in my inbox with the title Symbolic AI, and then it adds that to my, and then it adds the markdown heading as well. And if I close this now, and if I open my daily node again, we see that it has added this node to the bottom there. So that is why I like to, that is why I use this CLI, so I can create nodes from the command line, and that it's automatically added to my daily node, so I can keep track of when I created them. So if I open up this node again, Symbolic AI, and here's the text that I typed down. Okay, so Symbolic AI uses symbols and relations between them to solve problems. So it uses language, if I'm not mistaken. And the counterpart of this is subsymbolic AI. And subsymbolic AI is inspired by biological brains using feedback to train AI. Okay, so this subsymbolic AI is the opposite of symbolic AI, and subsymbolic AI is inspired by biological brains. So rather than using symbols, you're actually using data and using feedback to train AI to learn to recognize written numbers, for example. That's the example that she uses in the book. Here, maybe I can find that in the PDF as well. Here, this is the example that she uses. So this is a subsymbolic AI is used for pattern recognition. And then we're going to go into the perceptron definition afterwards. But the idea is that a subsymbolic AI is able to take an image like this and then learn how to recognize the number 8. That's an example of subsymbolic AI. So, learning to perform simple perceptual tasks. And the key idea is that it's inspired by biological brains. So, in the next concept that's important to understand here is then the perceptron. And then if I now run space zn, it will create and open this node in my Zettelkasten system using this CLI. And it should have also added that to my daily node. Let me see. Yes, here we go. It's also added to my daily node. So I'm just demonstrating how I can use this CLI from within Neovim as well. This is why you should learn Bash and Linux well so you can do these things for yourself instead of relying on other people's plugins that you don't really understand. So now I have the perceptron node coming from the subsymbolic AI node, and a perceptron is, if I check out my nodes, mimics a neuron, several impulses that will fire if a threshold is reached. So what is meant by that is that this is basically a perceptron, and it is mimicked by a neuron. So in your neurons in your brain, they have dendrites, which are inputs, and then the axon, the output, is whether a neuron will fire or not. So if you have a certain type of input coming in, and if the sum is then at a certain threshold, the neuron will fire. And a perceptron is the same. So in the case of recognizing an 8, then these grids have a numerical representation, and if the sum of that input then is at a certain threshold, then it is likely that it's a number 8. And by doing that over and over again, then you can benchmark the weights of these perceptrons, and when you link a bunch of perceptrons together, then you create something that's called a neural network. And that's going to be the next node that I have. So, I mean, this is already getting a bit deeper than I initially thought that I would go. I mean, I'm still just wrapping my mind around the definition of artificial intelligence and what it is and what it does. But I do think it is useful to learn about subsymbolic and symbolic AI. And it's a very important fact that this is the subsymbolic AI approach is inspired by the biological brains and therefore has a more, call it, organic learning approach. Yeah. Uses a more organic learning approach using several iterations of training and adjusting the perceptron weights to get more accurate results. And again, these are all my words. This is just my words, my thinking in this node, which I then can later use, for example, in an essay. So let's open Symbolic AI again. Use the symbols and relations between them to solve problems. And now I wonder, is symbolic AI then, are large language models then a form of symbolic AI? So I'm going to go to Claude and I'm going to create a new chat. So symbolic AI and then subsymbolic AI. I'm studying AI using Zettelkasten method. I wrote these notes. Is this a correct way of phrasing it? So as you see, I like to verify with Claude if what I'm writing down is actually correct, especially because I'm a content creator. So it's very important that I sort of fact check the knowledge that I put out there. And then also, is it correct? According to these definitions, it seems that LLMs fall under the symbolic AI category. Is that correct? Okay, so LLMs do fall under the subsymbolic AI category. So that's interesting because I initially thought it would be symbolic, and it's good that I fact-checked this. So let's see if I can. This helps me understand more. So symbolic AI works with explicit rules in symbolic manipulation, uses human readable symbols and logical rules. Okay, yeah. The reasoning process is transparent and can be followed step by step. Ah, okay. Yeah, that's a key difference because nobody really knows how LLMs work. I mean, they are trained, but you can't actually understand the decision-making process because it is abstracted away from human language. It's more like following a flow chart or a decision tree. And then subsymbolic works with patterns and statistical relationships, learns from data, uses distributed weight representations. Reasoning process is often opaque, black box is what I meant to say earlier. So it is correct. Okay, so that gives me some more insights. So I'm going to expand my symbolic AI node with, it does tie into related to algorithms. So symbolic AI uses transparent reasoning and human language. It's more like a flow chart. Claude described it as traditional AI. Okay. And decision trees, rule-based systems, transparent and can be followed step by step. That's an important one. Can be followed step by step. It's more like a flow chart. Claude described it as traditional AI. And then subsymbolic AIs. So then I have a node that will say LLMs fall into the subsymbolic AI category. Creating a new node about this. And the reason why is because LLMs learn patterns from training data rather than following explicit rules. They use neural networks. Okay, so everything that uses a neural network is subsymbolic AI. That's an important idea here. So anything that uses a neural network is a subsymbolic AI. Okay, and sometimes that is just the node. Sometimes my nodes are just the titles. So let me just verify this with Claude. Is this correct then? It's a bit more nuanced, okay. While neural networks are primary example of subsymbolic AI, distinction between symbolic and subsymbolic is more about the approach to processing information rather than the specific technology used, okay? Well, I'm happy with this. I think this is clear for my thinking, so I'm going to just keep that in. Okay, so that can go. LLMs fall into the subsymbolic AI category. That I also don't need to expand that a bit more. Well, maybe I could write, let me see. Why do they fall into that? Because they learn patterns from training data. Yeah. they use neural networks, adjust weights, and don't manipulate symbols. Okay, so rather than using symbols, they use statistical patterns. Okay. So those are my definitions of symbolic and subsymbolic AI. I have my definition of a perceptron. And again, I'm currently just interested in definitions and not going too deep into all of the details about everything, even though I just did. So those are a few notes that I processed. Now let me see, is there anything that I want to... Now I changed to my next notebook here. And now I go into neural networks. So that's an interesting definition that I also want to add here. But I don't have to add it here. So it's just going to be a new note, I suppose. CK new. Neural networks. So my neural networks node has this in it. Okay, so this goes into more about how neural networks actually produce results. So let me just finish writing what I have here. Okay, yeah, so this note I wrote about neural networks is basically going into the inner workings of neural networks. They're a collection of perceptrons. And let me just add that to my, can I? Add word to spell list, G, okay. So collection of perceptions, but instead of 0, 1, they compute a value between 0 and 1 called activation. Yeah. So these are my own words, but if I search for activation here, let me see. Yeah. So here, this is basically what it means, that if the sum that a unit computes is low, the unit's activation is close to 0. If the sum is high, the activation is close to 1. So instead of the neuron that we used earlier, let me see. Yeah. So in this image, this is the input. Then the hidden layer, which is the term that I defined. No, I didn't define it, but I don't think I need to for my own studies. But the idea is that this hidden layer then computes several outputs, and every output layer, so each of these layers get a number. So it's going to be, if you take 0 to 1, it's probably a 0.9 confidence that it, 0.6 confidence that it's a 0, but it's a 0.01 confidence that it is a 2, for example, because it's very different. So all of these are going to have a number between 0 and 1, and then 8 is going to be the highest, and that activation of that 8th layer is then going to be another output of this network. And then from that, you can deduce which one has the highest number, and therefore this image is most likely to be an 8. And this is what a neural network is. It has several layers of perceptrons, perceptron-like simulated neurons, and they take the input, process them, then output a digit, and these digits are then processed in order to come to a level of confidence of the output. So that is called activation. All of the layers lead to output layers, and the one with the highest activation wins. This is known as classification. So the classification of this image is going to be 8. It's hard to know beforehand how many layers are needed. It's usually trial and error. So this actually comes later, I think. That's more logical. So this is called a hidden layer, but this can be more layers. There can be, maybe there's a layer to process the top half and then the bottom half and then one that combines it. And the more layers there are, the deeper the neural network. So that is why you can refer to networks as having depth. And again, it's hard to know how many layers are needed, usually trial and error. So basically the definition here is a neural network is a collection of perceptrons. And rather than just true or false, they output numbers. And that's basically all I need to know for my current stage of understanding. So I can then cross out this node. And then next, my next node that I have is machine learning. So do I already have, let me see. No, I don't have a different node about machine learning yet. So maybe I will just create a node called machine learning. Seek a new machine learning. And I know this one is related to machine learning. So why is it not opening my markdown? Links. Yeah. Okay, so I want to link it to that node and here we go. Now it's thinking. Okay. Machine learning is a branch of AI where machines learn from their own data or experiences. That was one node that I already wrote. The next one, or this node, actually contains the following text. So I really like this definition, algorithms that enable computers to learn from data. So yeah, I mean, this node basically says something similar. And it contains this thing that we wrote in Claude. So I kind of like this. I will keep that around. But this is going to be my machine learning main node. And I wrote this in my own words because I remember writing this, and I don't need to refine this more. This is my own definition that I deduced from the book. So I'm going to keep this like this. Then the next node is called General AI. And here I wrote okay. So this node, this definition is about general AI. Another definition that I wanted to lock down, an AI that's equal or better than human intelligence in most ways, also known as AGI. So that's another definition I wanted to lock down, and that is basically the end of the nodes that I have so far. So now I have all of these nodes on my daily node currently, but I want to also have, I also need to add these to the book node that I had. So here I can just yank all of these because they all came from the same node. So I can just paste these in. And then what I do is I prepend that with a, let me see, Control V. Okay, so now everything has a button in front of it. Okay, so these are all nodes that are coming from this one book. And then there are a couple of links that I want to make, but this is basically what you see me doing now is just the writing process and getting it down into Vim, because I really like switching windows using Vim and such like. But usually the linking itself I would do from Obsidian. So symbolic AI and subsymbolic AI are definitely related. So I will link this to subsymbolic AI. Then this one had the perceptron link already, so there are already a few links there. That's good. LLMs fall into the subsymbolic AI category. Well, that one has a backlink from this one, so that's fine. Anything that use a neural network. Yes, okay. So everything that's linked, I'm just going to move straight to my Zettelkasten, because all of these nodes end up in my inbox. As you see here, here's my inbox. And now I can just start moving those to my Zettelkasten as I go along. So move this to Zettelkasten. And this can be moved because it's linked. Perceptron is linked. Moving that. This one is linked. This one is linked. Neural networks. This one also has links, and this can be linked to deep learning or deep neural networks, but I think this is fine for now. So I can just move that to the Zettelkasten as well. Machine learning. That one I want to have on my main artificial intelligence node. Here. Machine learning. And this one can go because it's already linked to the machine learning node. And then I want to have symbolic AI and subsymbolic AI here. Okay. That's basically the definitions that I am most interested in. And then the perceptron definition is linked here. So if I need it, then I will naturally end up there. And then finally, general AI is also an important definition. So that one I also want to have here. General AI. So now I've processed a bunch of what we call fleeting nodes from my notebook here. And now they are in my system. So I actually cross these out. I just take my pencil and cross these out. So I know that these are actually processed and in my system. They're all linked and added to my Zettelkasten. Now in the next one that I would like to do is that I'm going to, since I'm building this sort of mind map about AI in my mind now, I'm going to be actually drawing this out using Excalidraw, and that's going to be the subject of the next video. So let me know if you like this. If you're into note-taking, you should definitely check out my free community. It's all about note-taking. I have tons of courses on Obsidian and how to use the Zettelkasten method. Check it out. I think you might like it. See you in the next one.